Hello and welcome to the 2.5 notes. This is a section over transformations of functions. So when I talk about transformations of functions, what we're doing is we are moving the graphs. So we are moving graphs, okay? And what that means is that we are moving them left or right. We are moving them up or down. Okay, we are reflecting them, and we are either making them fat or skinny. We'll talk about that here in a second. So we've got all these different rules that I've got on your notes on how this all works, okay? So you've got vertical shifts, you've got horizontal shifts, reflections, and then vertical stretching. So that's, what I did, left or right, up or down, reflecting, and making it fat or skinny, okay? So the first thing that we have to understand are your basics in parent functions, okay? You have a constant function, you have a linear function, absolute value, standard quadratic, square root, cubic function, and then a cube root function, okay? So these are all functions that you do really need to know by heart, just kind of what they look like as basics. But what I want to talk about is, a general rule of thumb for doing transformations. So general rules, okay? And what I'm going to first start out, I'm going to use the parent function y equals x squared. Okay, I'm just going to use your standard quadratic. And what we use is we use this. We use the notation y equals a parentheses x minus h parentheses squared, and then plus k. Okay, and so first of all, k is your vertical shift. Okay, that's going to move it up or down. That's your vertical shift. And this follows the sign. Okay, so if you have something on the outside where it's like a +3, okay, you're going to move it up 3 units, every point 3 units. Okay, h is your horizontal shift. Okay, and your horizontal shift is going to be the opposite of the sign. Okay. So if it says, say, something like, x minus 3, that means that if it's a -3 on the inside and you read it like that, that means you're going to move it to the right 3, okay? And we'll talk more about that here in a second. A is your stretch and shrink. So your stretch slash shrink, okay? And when you stretch it, that means that you're going to get fat. Okay, the graph is going to become wide. If you shrink, that means it's going to be skinny. And the way I know to do that, if you're going to make it fat, that means that the a value is going to be less than 1, but also greater than 0. If you're going to make it skinny, that means that your a value is going to be larger than 1. Okay, so when I make this, if the graph is fat, and what I think about, the graph is fat, so a is less than 1. And I think of this. If someone is fat, that means that they need to eat less. Okay? If the graph is skinny, that means that the person needs to eat more. Okay? So just that's my way of remembering those. So that's the general rules on all transformations. Okay? The thing that you have to realize is that your horizontal shift is always inside the parentheses, or it's inside the absolute value, or it's underneath the radicand or the cube root symbol, okay? Your vertical shift is always going to be on the outside. It's going to be, outside the absolute value, outside the squared, outside the square root, the cube, and the cube root. Okay, so let's look at a couple of examples on how this all. All right, so I want to take a look at this example on the next page. Use the graph of f of x equals absolute value of x to obtain the graph of absolute value of x plus 3. Okay, so the first thing I do is I usually graph my parent function. Okay, so my parent function is the absolute value of x, okay, and that's just a V-shaped graph like this. Okay, and if I want to transform this graph and do a +3, then what I'm doing is I'm going to physically just shift this graph up 3 units, okay, and that 3 is on the outside, so I'm going to go up 1, 2, 3, okay, and that my graph has been shifted up all those units, okay. Let's say I wanted to do this. Let's say I wanted to do g of x is equal to the absolute value of x plus 3, and we keep that on the inside. Because this 3 is positive, and this means we move left 3 units, okay? And so with that, I want to do this. I'm going to move this over 1, 2, 3, plot my point, and we're going to make our graph like this, okay? Let's say I wanted to do something like this, where I wanted to do, say, g of x is equal to 3 times the absolute value of x. Okay, because this value is large, we're going to make this graph skinny. Okay, and kind of what this does is this is going to make it so that, you know, if I start here, you know, I can up 3 over 1, you know, this now has like a slope of 3 to it. Okay, same thing on this side. And the graph is going to become skinny, all right? So, you know, a lot of these functions are going to be of that form where, you know, we just have transformations. And if we understand what the parent function looks like, then doing the transformations really isn't too bad, okay? So I want you guys to go ahead and do that, and we'll see you soon. Thanks a lot. Bye.